God bless you.
If its vertex is on the center of a circle, it's a central angle. And we said the measure of a central angle is equal to the measure of its arc. Then we talked about inscribed angles. What makes an angle an inscribed angle? Where's its vertex? On the circle. All right? And we said the measure of an inscribed angle is equal to half of its arc. Okay? We also dealt with chords intersecting in a circle and finding the measures of the two pieces that were created. All right, A plus B is one chord, X plus Y is another chord. Does anybody remember how to set up and use these pieces of information to find a missing segment?
A multiply times B.
Yes. You simply multiply the two segments of one chord, and that is going to be equal to the product of the two segments of the other chord. Very simple. We simply multiply, and they're equal. Y'all remember that?
Yeah.
Okay. We had secants or tangents that were crossing outside of a circle. And we were dealing with measures of segments, not angle measures right now, just measures of segments. This is also a proportion that we worked out to get a little multiplication thing going. Chandler, do you remember what it is?
Outside times the whole other point.
The outside section, the part outside the circle, multiplied by the whole thing, which in this case would be A plus B, is equal to the outside section of the other one, which would be X, multiplied by the whole thing, which is X plus Y, not X times Y. All right? Now those are two secants. Okay? All right, these are two what? Tangents. Okay? These are two tangents. First off, what do we know about two tangents that connect at the same point? They're equal to each other, so A is actually equal to X. Another thing we know based off of that last thing we did was the outside section multiplied by the whole thing, which would be A squared, is equal to the outside section multiplied by the whole thing, which would be X squared. But I don't think we're going to ever have this. We would have a tangent and a secant instead of two tangents. But I wanted to refresh you that, yes, those two are equal to each other. We also know something else. If a line is tangent to a circle, then what's its relationship to the radius of the circle at the point of tangency? It forms a right angle. And here we form a right angle. Okay, that was another thing that we talked about with the circles.
So what do you do if one's a secant and one's a tangent?
If one's a secant and one's a tangent, okay, well, let's just do this. Let's just call this B and C. Then A squared is equal to the outside section multiplied by the whole thing. Okay? Because the outside and the whole thing is the same thing for A. All right. In this picture, let's see if we remember. If a radius of a circle is perpendicular to a chord, what does it do? It bisects the chord and it bisects the arc. So, if y'all recall using this information, if I wanted to find the radius of this circle, this is 8. I'm drawing that the chord has a measure of 8. If I draw a radius from the center to the outside, I have formed a what kind of triangle?
A right triangle.
A right triangle. And I know that the bottom here is what? 4 because the chord has been bisected. I know that this 60-degree arc has been bisected, which means this is 30 degrees. So what's this angle? The central angle forming it. 30 degrees. So you have a 30, 60, 90 degree triangle. So what's the radius of that circle? 8. The radius is 8 because this represents the radius and it is the hypotenuse while the short leg is 4. And the hypotenuse is twice the short leg. Okay? Y'all need to remember all that stuff. Okay, and then we had chords intersecting inside a circle forming angle measures. If I was looking for or asking for the relationship between angle 1 and arc X and arc Y, what would you tell me? Say it. No. This is not necessarily on the center of the circle. Okay?
Equals half x times y.
If y'all recall, the angle is equal to the sum of the two arcs divided by 2. Now, you might be told the two arc measures. Okay, plug it in, find the angle. You might be told the angle and one arc. Okay, plug in what you know and find the missing piece. But this is your standard relationship. Then in this case, if we were looking for angle 1, you subtract. The measure of angle 1 is equal to the larger arc, which in this case is y, minus the smaller divided by 2. And no matter which two pieces you're given, you can find the third piece if you remember the standard relationship and plug it in and solve the equation for the missing piece. Exactly. Okay? Then we had stuff like, oh, I ran out of stuff. We had stuff like this. Oh, yeah, I'll go back. In a circle, equal chords have equal what? Y'all remember? Equal arcs. Okay? So if we said that this was 10 and that this was 10 and that this arc measure was, say, 80 degrees, what would the arc measure of A be equal to? 80 degrees. Because they are formed by two equal chords. Or if we had said the reverse, those are both 80-degree arcs, what's the measure of chord A? 10. Because equal chords have equal arcs. We also said that if two chords are equidistant from the center of the circle, which it doesn't look like it now, but let's just pretend. What do we know about the chord measures? They're the same. And yes, they are bisected because that little line is perpendicular to it. But if I said that this entire, well, let's just do this. Let's say I said this was 5 from here to here. And then asked you what's the measure from here to here. What would you tell me? It's 10. Because number one, these have been bisected. So this top chord is 10. And since they're the same distance from the center, this bottom one is also 10. Okay, all the little things in that chapter that we had to know. And then finally, in chapter 11, we covered the first 3 sections, which is what we tested on last week. Let's go over our major things that we knew. It was some formulas. Okay, it was area formulas. We started with a rectangle. All right, what's the area of a rectangle?
Base times height.
Base times height. What's the perimeter of a rectangle? What other shape shares these same formulas?